Okay, everybody, so following up after the description I gave you guys yesterday of how the HIMSS demo was working, we're going to walk through basically what we showed everybody at HIMSS. There were multiple parts to it. The segment that has to do with the actual FHIR demo is what I'm going to walk through right now. And, on the theory that, the best thing to do is to tell them what you're going to tell them, and then tell them what you told them. We had to frame this for everybody that was watching. Because it is, when you're watching it, a bit tricky to know what's going on. The essence of this is we have this use case where a veteran has been transferred, presumably from the DoD, and the VA now has to take this FHIR message from, Cerner, and decide where to populate the patient record based on where they live. He lives in Tampa, he's unmarried, so the very first message that you're going to see is going to come from the submit UI, which is our hypothetical future MPI, as you were, is going to send a message through the federator to Bay Pines, and this is going to be in FHIR format, and because we have a FHIR adapter that we've implemented on top of VistA.js that knows how to translate the FHIR message into something Vista understands, that's going to trigger on the mirror in the back end. We have an adapter here, an event source adapter, that picks up that something changed in the journal file, determines this has to do with the patient demographics, and realizes it has to create a FHIR snapshot, which then gets sent to the FHIR data service. Now, the FHIR data service receives this, it checks with the master identity index, says, do we know this person, this new patient? We realize we don't know this patient, and we store the data in the FHIR database in ForeverDB. Now, at this point, if we were to check what data the ForeverDB has for that patient, you'd get a representation, and this UI was really just a visualization of the FHIR data. It's not a UI we would expect the user to use. In fact, it doesn't have to be a UI. It could be a process that's running as part of an overall approach to data management that looks for certain kinds of discrepancies that are automatically fixable versus some that might require human workflow. So this data coming from here could be going to an actual application like MedRec, the medication reconciliation app we've been working on, or it could go to some automated bot that just knows how to look for particular kinds of discrepancies. In any case, this is FHIR data all the way, right? This from here is FHIR. It's getting stored in the database in FHIR format, and it's the entire FHIR spec is actually the schema for that database. So now we have the patient. The next step in the use case is they move to West Palm. The guy moves to West Palm and gets married. So at this point, we're going to seed the record in West Palm. It's identical except for the married designation. And now that gets picked up on the mirror in West Palm, which sends the data to the FHIR service, which then checks with the master identity index, realizes we do know about this patient, and the reason we do in this hypothetical scenario is because the ICN has been provided by MVI, so that's how we can tie these two records. We store the data in the FHIR database, so now there's two FHIR messages, one from Bay Pines, one from West Palm, persisted. So now when we see in the UI, we can catch the discrepancy. We can say, okay, there's a difference here, there's a disagreement here. We don't have any other information to tell us that it's just stale data, so we treat it like a discrepancy. At this point, in this UI, we have a very simple way to show updating the data. This isn't, again, how we would expect users to really do this, just to visualize what's happening. And when we correct it, now that FHIR data service is going to receive the resolution to that, which in this case is just, West Palm's right, Bay Pines is wrong. But in a real world scenario, there could be differences between both of them. So then the FHIR service sends the new snapshot, the new canonical truth, to both Bay Pines and West Palm through the federator. Both of them update their local store to be in alignment with that new snapshot. And we see it replicating through the mirrors. So at this point, both snapshots will be identical in terms of data. They'll just have different provenance info potentially. This will then go the usual step, check with the me, update the data. And now when we pull this down into the UI, you'll see that there's no longer a discrepancy. Okay, so one thing I'll explain before I show you the actual thing working is why we do it this way. Why do we go to mirrors instead of to the actual database? And the reason for that is, if you ever heard of the Heisenberg principle, you can change something just by observing it. Developers have a variation of that called the Heisenberg bug principle, where it only shows up when I'm not in a debugger, right? So what we don't want to do is bring change of any kind to the production system. So we work off of replicas. Depending on the database system, there's different kinds of replication. In this case, we're using cache mirroring, which is among the choices like the best choice to use. And this allows us to detect change unobtrusively to the main target. So even if we accidentally brought that down, nothing bad happens to the data here, and the minute this comes back up, it'll resync and everything will be good. So it's a very safe strategy for monitoring change on a target database. So anyway, that's what you're going to see in the little video that we've got coming next, and I'll walk you through it in the same way so you can relate what you're seeing here to that visual picture. All right, so in this case, we're going to log into this thing we call Submit UI, which is basically a little web page created specifically for showing these demos. And you'll see, pause it. You'll see the first. Where'd you go?
Sorry, it works differently on Windows and on a Mac. Looking at this.
All right, so once it gets to that part, just pause it briefly. So I want to show you once it's kind of up there. Okay, stop here. So when this thing connected, we chose a particular variation of this patient name for the demo. The Submit UI connected to the federator, and these are the 3 sites that it's aware of, right? So that's to populate this dropdown. So what you're going to see as things happen, you're going to see the messages from this application showing up here, including the FHIR messages it sends, any responses it receives as it's interacting through the federator. This is the federator log, and you're going to see all traffic going through the federator as it's happening here. This is the 2 vistas that we're going to use in this use case, Bay Pines and West Palm. We're going to monitor their logs, and they're going to be interleaved, so you're going to see them happening in real time. And then this is the mirror. So we're going to be following the 2 instances on this side, and you'll see those messages coming from the mirror. So the mirror is going to pick up the change in the journal file and generate a FHIR snapshot. Here you can see all that action here. And then this is the FHIR data service showing its requests and responses. Okay, so there's a lot going on. There's a lot of moving parts, but if you have that mental model of the picture we drew before, you can kind of see what's going on. So what we're going to do first is we're going to submit. Go ahead now. We're going to submit this patient to Bay Pines. And you see this is the basic FHIR data for the patient resource snapshot. So you're going to see the call to the federator. You're going to see it go to Bay Pines. You're going to see the mirror pick up on it in a second here, and then you're going to see the FHIR data service get that data. So within literally a couple seconds, bang, we've got FHIR data. So now we're going to go to the FHIR data service UI. We're going to go by ICN. We're going to fetch the patient, and this is just a visualization of the FHIR data, so you can drill down into it. And what you can see right now is he's single, never married, and it has all the adornments of FHIR data. If you look over here, you'll see the responses as they came in. So he's got a new DFN and everything. Now we're gonna publish the same patient to West Palm, but we're going to change his marital status. This is so that we can show the discrepancy getting detected in the system. So we're going to submit it. You're going to see the action happening here, here, and then you're going to see it here, and then eventually down here as well. So there it is, full stack. So now we're going to go back to the Synchronize UI. We're going to grab it's the same ICN. We're going to search for the patient by ICN. And there it is. We have now, there's a discrepancy we've detected between the 2 instances. So we're going to drill down into that, and you can see them now plainly stated as Bay Pines and West Palm. And we're going to declare, these are actually 2 pieces of information that constitute marital status in FHIR. And then you'll see now the whole stack gets updated. He sends the message to the federator, both of them update. And now when we refresh, no more discrepancy. So that went full stack all the way around, updated both vistas. They're now in alignment with marital status. And that's basically the demo. Any questions?
So the discrepancy happens because the record was submitted to 2 different hospitals, right? So like one is
correct.
Okay.
Yeah, and we did that knowingly because what we were trying to show was the actual detection of that on FHIR data service, which is storing the data. You can think of the ForeverDB as the source of truth about the sources of truth. And what we then saw was that as the new patient was created in West Palm, the system now was aware of one data discrepancy that needed to be resolved, and we were able to make a request and get the data back and see the discrepancy. So the data at this point is in a superset of FHIR that also is augmented to be able to show when there's a difference or discrepancy.
So if we were submitting that change of marital status to the same hospital, it would not bring up an error, right?
No. So say it again.
Like if we just changed the status and submitted it back to the Bay Pines, it would not cause a discrepancy, right? It would
Well, so if we just updated the Bay Pines and then updated the same data to West Palm, there'd be no discrepancy. That's correct. Yep. In reality, there's a lot more information than just stuff like marital status that's out of sync between VistA instances. And Doc Shore, I'm sure, could give you quite an understanding of why and how that is from a practical point of view. Very likely addresses and phones and all kinds of stuff would be different in both systems. And the idea here is whatever that definitive truth is at that point in time when someone is verifying this officially, right? Both systems then have an opportunity in this architecture to update themselves to be in alignment with the new truth, quote unquote. In reality, there's a lot of policy that would never prevent this from happening. But that's okay. As long as we can detect the discrepancies and say what we know the new truth is, then you can at least have a manual process to tell people you need to update your systems because it's been determined, whatever. So it could be a manual process, but we've also shown that with the policy kind of barriers removed, it could be a totally automated process as well. And that, like I say, this really resonated with folks at the Interoperability Showcase. I don't think anybody ever saw a round trip like this with FHIR. I don't think anybody's tried to update like two systems like this in any of those demonstrations. So we really got a lot of attention with this. And what I'm looking at is how can we take the kernel of this and everything that we've learned from what we did with VistA.js and MedRec and take those things to the next level. Now that we don't really have the constraints of the VA's OI and T kabuki dance to interfere with that. That's what we'll be recording a little bit later. I'll go through what I envision the near term and the long term strategy to be to make this this kernel of a thing a full stack, Apex Unify with particular importance to what we want to do on the med management side going forward. So that's this part. I guess you can end this here.
Bob?
Yep.
Jim's got a question.